Welcome back, students. Welcome back to the second video for lesson 5.1. In this video, I will do some more examples with you of using trigonometric identities to simplify or factor trigonometric expressions. There's a lot of this in calculus, which is why we're doing it in pre-calculus. So once again, notice and remember that these red numbers here indicate what exercises in your assignment these examples pertain to. So if you're stuck on number 20, for example, look at this example 2 to give yourself a hint. Okay, without any further ado, let's take a look at simplifying this expression right here. You'll notice that both terms have a sign in it, so it's probably pretty logical to you to go ahead and try to factor out that sign. So factoring out the sign, we're going to be left with this. Don't forget the -1. This should look somewhat suspicious to you, a little bit familiar. It should look kind of like a trigonometric identity that you're very familiar with, this one right here. However, you will notice that it's a little backwards. If I subtract cosine from both sides, I will get this. Now, this expression, 1 minus a cosine squared of x, and this expression look similar, but they're not the same. So we learned a while ago that one trick to flip this around, basically, was to factor out a negative. So if I factor out a negative, these guys basically switch signs. The one which was negative becomes positive, and the cosine squared, which was positive, becomes negative. So now, using substitution, I know that 1 minus a cosine squared of x equals the sine squared. And therefore, my answer is negative sine cubed of x. Remember that that can also be written as, well, let's not do that here. I don't want to confuse you. Just leave it at that. Okay, try the second one. Pause the video. You try it. And then play it again and see if you got it right. Okay, so on this one, you should have factored out the cosecant. And if you factored out the cosecant, you're left with this. Well, that looks familiar. Taking out a -1, we can flip this around. And therefore, this is the cosecant of x times the sine squared of x. Now, wait a minute. The cosecant. That's just 1 over the sine. So what I really have here is -1 over the sine of x times the sine squared of x over 1. These kind of cross out, and you're left with negative sine of x. And that should have been your answer. Did you get it right? I hope so. Let's go to example number 3, right down here. And let's factor this thing. So to factor this, what you really need to be thinking in your head is you need to be thinking, well, let's see. What would it be like to factor 4x squared plus 1x minus 3? In other words, let's replace the tangent with just an x. So tangent squared of x, just think of it as x squared. And the tangent of x, just think of it as x. Can you factor this? Well, you should be able to. So we can factor in 2 binomials. And for example, this would be 4x and x. This would be 3 and 1. Put the positive there, put the negative there, and yeah, we're set. Think about that for a second. Now, if this trinomial factors into this, then this trinomial is going to factor into this 4 times the tangent of x minus 3 times the tangent of x plus 1. You try it. Try foiling this. Try multiplying this times this, this times this, this times this, this times this. See what you get. Promise you'll get that. Pause the video once again, and you try it yourself. Here's what you should have. This is a difference of squares. Pretty simple. This should be a secant of x minus 3 times a secant of x plus 3. That's it. Easy. Let's go down to example number 4. We are to factor this. Now, you'll notice that there's a cosecant squared and there's a cotangent. You're not going to be able to factor that. So let's go to our identities and let's see if there is an identity that will allow us to get rid of either the cotangent or the cosecant. So let's look. Oh, what do you know? Look at that. Over here in one of the Pythagorean identities, I have 1 plus the cotangent squared of x equals the cosecant squared of x. Which tells me I can replace this with 1 plus the cotangent squared of x. Then I'm going to tack the rest on right now. Combining a few like terms, well, it's not too complicated here. We're just going to combine the -3 and the 1, and then I'm going to factor it just like I did in this example up here. So let's see. That's kind of like factoring x squared minus x minus 2. That factors into, let's see, x minus 2 and x plus 1. So this will factor into, oops, that's ugly, the cotangent of x minus 2 times a cotangent of x plus 1. So pause the video once again, and now you try it using that one. Go for it. Did you recognize that there's a Pythagorean identity that says that the secant squared of x equals the tangent squared of x plus 1? That's just a Pythagorean identity. So what I can now do is I can replace this term with this expression. So let's do it. So I'm going to get the tangent squared of x plus 1. That's the secant squared. Plus 3 times the tangent of x plus 1. All right, combining those ones, I'm going to get the tangent squared of x plus 3 times the tangent of x plus 2. And that is going to factor just like x squared plus 3x plus 2 would factor. So let's see, that one's easy. My 9th graders could do this one. Ta-da! And therefore, your answer is going to be the tangent of x plus 1 times the tangent of x plus 2. All right. Hopefully you're doing okay with these. You're going to have an ample opportunity to practice it in the assignment coming up. But I will stop this video right here, and you'll have to go to video number 3 to keep on going. Bye.